Today I'm going to tell you how all the messages and information that you exchange online is protected with the help of encryption. Whatever message or information that we share online is always sent in an encrypted form to prevent it from being hacked. That is what WhatsApp means when it says that our chats are end-to-end encrypted. Only the person sending the message and the one receiving it can read the message. Encrypting a message prevents it from being hacked. All the online money transfer and online banking would not have been possible if encryption was not there. So encryption helps in changing your message to an unreadable form which can only be decrypted by a unique private key. There are several types of encryption available today, but the one I'm going to tell you about is called the RSA encryption. It was discovered by three geniuses whose name had the initials R, S and A, and thus it got its name RSA encryption. It is the most widely used encryption method and is considered as one of the most safest method of encryption. So the basics are simple. Everyone has their own private key and there is a universally accepted public key. Whatever message you want to send has to be converted to an encrypted form, and it requires using both the private and public keys to encrypt the message, and it can only be decrypted by the person having another private key and also the public key. Now the rest of the process is completely mathematical but not too tough to understand. Before we move forward, you need to understand what modular arithmetic is. In simple words, you can call mod as the remainder function. Now, as our imaginary name suggests, when applied to two numbers and after performing division, the mod function gives the remainder as the answer. For example, 5 mod 31. 31 divided by 5 gives 1 as the remainder. So in this case, 5 mod 31 is equal to 1. Few more examples. 6 mod 38 will give 2 as the remainder. So 6 mod 38 is equal to 2. 7 mod 21 does not have any remainder. So 7 mod 21 is equal to 0, and so on. Pause the video over here and think of a few more examples on your own to understand this topic in a better way. So now coming to the encryption part. Suppose you want to send a message to someone. For simplicity, let that message be just a single letter, for instance B. Now you need to convert it into a number so that the encryption process is possible. So let's number the alphabets from A to Z as 1 to 27, and everyone knows about this process. This is not the encryption. We have related a number with B, which is 2. So now let us encrypt the number 2. The role of your private key and the public key begins here. Take any two numbers, for example 5 and 14, as your private key and the public key respectively. The formula to encrypt your message is the number related to the message is raised to the power of your private key mod public key, which in this case is 2 to the power 5 mod 14, which equals to 32 mod 14, which is equal to 4. So the number you send to the receiver is 4, and now it's his job to decrypt the original message. So to decrypt the message, all he needs to do is apply a simple formula. And similarly to the sender, he also has a private key, so let it be 11, and the public key being public remains the same, which is 14. The formula to decrypt the message is similar. Take the received message, raise it to the power of the person's private key mod the public key, which in this case will be equal to 4 to the power 11 mod 14, and then using a calculator we'll find the value will be equal to 2, which is exactly the message which was sent initially. These processes for encryption and decryption will always remain the same and yield the expected result. The only condition is to find a proper public and two private keys. You cannot take any random numbers as the keys, as you must have thought is what I have done while explaining, but there is a proper method which I have used. Now I'll discuss the derivation of the encryption formula and how the public and private keys are decided in the upcoming videos. So stay tuned and thanks for watching.